looking at what? Linear algebra. Linear algebra. The way we see linear algebra before is much complex than that. Normally you'll be given a system of linear equation, let's say simultaneous equation specifically. Given a simultaneous equation, what are our tasks? Our task is that you want to know the value of what? X, Y, Z, right? This value of X, Y, Z, we are going to substitute back into the original equation if this value will satisfy the left hand side and the right hand side. This is what I'm saying. Let's say you are given this equation. Let's say you have 2x plus y is equals to 4, right? Say equation 1. And you are given 4x plus 3y is equals to 7, say equation 2. These are system of linear equation given, right? These are equation, meaning simultaneous equation. In this case, you want to find the value of x and y. You know the value of x and y. Then substitute back into this equation. The left hand side must be equals to the what? Right hand side, right? This is the knowledge that we have when it comes to what? Linear algebra. But then linear algebra is much more advanced than this, right? So as an engineer, you want to understand linear algebra in a practical way, meaning that this corresponding value of x, y, z that we've gotten, then at the end we are going to make a comment. With this comment, it helps us to solve problems as an engineer, right? The difference between engineer and mathematician is that mathematician, they only solve questions. They only solve pairs of equations, then get their value. But we as an engineer, we want to use this value that we've gotten to solve real life problems, right? That's what linear algebra means basically. So by definition, linear algebra is a branch of mathematics. Linear algebra is a branch of mathematics. Linear algebra is a branch of mathematics that deals with the study of different sets of linear equations. That deals with the study of different sets of linear equations used to determine the unknown variables. Used to determine the unknown variables in this equation. Used to determine the unknown variables in this equation to check if the equation is satisfied or not. So let me repeat that. I said linear algebra is a branch of mathematics that deals with the study of what? Linear equations, right? Used to determine the set of unknown variables. Used to determine the value of the unknown variable present in this equation. Present in this equation to check if the equation is satisfied. Meaning, is the equation a consistent equation or an inconsistent equation? With linear algebra, we are going to know that. And by the time you know that this equation is a consistent or inconsistent equation, as an engineer, you're able to apply it to a real life problem. And that's the aim of this topic. You already understand what linear algebra means, right? You see the reason why we need to understand this. This is the theory aspect, and it is very, very important. Once you understand the theory aspect, given any question, you'll be able to apply it. You reason practically. That's just it. So now, I've given you guys the definition of what linear algebra means. So the aim is that, let's say you are given this equation. Let's say you are given 2x plus y equals to 4. Say equation 1. And equation 2, you are given 3x plus 2y is equals to 6. Say equation 2. Under linear algebra, you want to know the value of x and you want to know the value of y. That by the time you substitute into this equation, the left hand side will be equals to the what? Right hand side. Now let's say you have the value of x equals to 1 and the corresponding value of y when x equals to 1 is 2. Similarly, when x equals to 4, the corresponding value of y is equals to 3. Do you know that there are some cases whereby by the time you substitute these two values of x and y, your left hand side will be equals to the right hand side when x equals to 1 and when y equals to 2. This same equation, by the time you substitute when x equals to 4, y equals to 3 into this same equation, your left hand side will still be equals to what? Your right hand side. So that's what we want to see. In this type of case, we call it Manysolution, but you get to understand what I'm saying. Now, let's take down types of method or different types of method used to solve our linear equation. Method of linear equation. Methods of linear equation. By method of linear equation. Now let's take it back to the basic understanding that we have. Given this two pair of equation, you want to solve this equation, what will be the first method that will come to your mind? So you are given this with what we've been doing so far in mathematics. Given these two equations, what will be the method that will come to your mind? Elimination method, substitution method, and all of those methods, right? So that's what we are saying. When we say method of linear equation, what are these methods that we can use to solve our linear equation? The first one, we have the Sarus method. Number two, we have the Cramer's method. I believe you know the Cramer's method. That's determinant. We have the Cramer's method. Number three, we have the decomposition method. Number four, we have the reduction method. Under reduction method, we have Gaussian elimination method and Gauss-Jordan elimination method. Gaussian elimination method. And we also have what? Gauss-Jordan elimination method. Method of linear equation. Method of solving linear equation. The first one is what? Sarus method. The second one is Cramer's method. The third one is what? The decomposition method. Then the fourth one, reduction method. Under reduction method, we have Gaussian elimination method, also called the row echelon form. Row echelon form. This is the spelling. Row echelon form. Then your Gauss-Jordan, it is called the reduced row echelon form. Reduced row echelon form. Hope you are getting the idea. So for today, we want to look at, this is our interest, this is the topic of the day, reduction method, which is Gaussian elimination method and Gauss-Jordan elimination method. Any questions so far? Okay, let's recap all what we've said. We said when it comes to linear algebra, we want to see linear algebra in different approach or in a different way. We want to see linear algebra as an engineer. You know, linear algebra is what we've been doing from secondary school. You'll be given simultaneous equation, then use any method of your choice. Say elimination method, substitution method, right? But then it is more than that, in the sense that this value of x, y, and z that you've gotten, you can comment on this value, then apply it to a practical scenario. Now, we now said method of linear equation. The first one is the Sarus method. You get to see what Sarus method means later. The next one, number two, is Cramer's method, meaning your determinant. Number three, decomposition method, the advanced part of row reduction. Then the fourth one is reduction method. Now, under reduction method, we have Gaussian elimination method and Gauss-Jordan elimination method. And another name for Gaussian elimination method is called row echelon form. While Gauss-Jordan, it is called what? Reduced row echelon form. And as we've seen here, we said, given this system of linear equation, your different value of x and y can satisfy this equation at the same time. Meaning, let's say when x equals to 1, y equals to 2. And when x equals to 4, y is equals to 3, can satisfy this equation. Meaning, using those values, the left hand side is still equals to the what? right hand side, irrespective of the value of what? X and y. So this will bring us to what we call the type of solution under linear algebra. This will bring us to what we call what? The type of solution under linear algebra. The first one, we have unique solution. Number 2, we have many solution. Number 3, we have no solution. When we say unique solution, by the word unique solution, say you have the system of linear equation, meaning that for that equation to be satisfied, for the left hand side to be equal to the right hand side, each unknown variables, meaning x, y, and z, only have a unique value. I don't know if you are getting the message. Consider this equation. Say this is x1. Say this is x1 plus y1 plus z1 equals to a. And say this is s2 plus y2 plus z2 equals to b. And s3 plus y3 plus z3 equals to c. Say this is equation 1, equation 2, and equation 3. You know, you want to solve this equation. The idea is that left hand side must be equals to what? Right hand side. And how do you check if left hand side is equals to right hand side? Depending on the value of x you've gotten, right? So by unique solution is telling us that for the left hand side to be equal to the right hand side, x, y, and z only have a unique value. So let's say that when x equals to, consider this, says case 1. For case 1, when x equals to 2, y equals to 3, and z equals to 4. This is the first set of your, this is the value of your unknown variable for this equation. Then for case 2, say x equals to 3, 4, sorry, say x equals to 3, y equals to 1, and z equals to 2. Meaning for this equation to be satisfied, for the left hand side to be equals to the right hand side, when it comes to the unique solution, it means x must not be less than 2 and x must not be greater than 2. Meaning the only value of x that will satisfy this equation for x is when x equals to what? 2. Similarly, for y, when y equals to 3. Similarly for z, when z equals to what? 4. But this same equation, let's say you have another system of linear equation. Do you know that both case 1 and case 2 can satisfy this equation at the same time? Are you getting the idea? Meaning when x equals to 2 can satisfy this equation. When x equals to 3 can also satisfy. Similarly for y and z. So you get to understand better, don't worry. So by unique solution by definition you can write. This is a type of solution. This is a type of solution that gives a distinct value. This is a type of solution that gives a distinct value of the unknown variable, of the unknown variables, satisfying the system of linear equation. Unique solution. This is a type of solution. This is a type of solution that gives a distinct value of the unknown variables, satisfying the system of linear equation. Satisfying the system of linear equation. Types of solution. With this type of solution, that's when you give your comment if your system of linear equation is consistent or inconsistent. So the first one, we have unique solution. We have unique solution. And by definition, unique solution is telling us that this is a type of solution that gives a distinct value to the unknown variables, satisfying the what? Linear equation. Satisfying the linear equation. Now consider this equation. Let's say x, the first equation, x squared equals to 4. X squared equals to 4. And the other equation, 2x plus 1 equals to 5. Say this is equation 1. Let's say this is equation 1. And let's say this is what? Equation 2. Now let's solve equation 1 using basic mathematics. From equation 1, what's the value of x? X squared equals to 4. It implies what? X is equals to plus 2 or minus 2. Meaning this equation has no unique solution. Are you getting the idea? Meaning when x equals to 2, it will satisfy this equation. Meaning the left hand side and the right hand side will be equal. That's when x equals to 2. When x equals to minus 2, it's still going to satisfy this equation. Meaning the left hand side will still be equal to the what? The right hand side. Meaning for this equation, it has no unique solution. Let's check this other equation. Checking this other equation, solving your basic mathematics, you then have 2x equals to 5 minus 1, right? 2x becomes what? 2x equals to 4. Divide both sides by 2. X equals to what? 2. X equals to 2. Now let's do our checkings. Given that 2x plus 1 is equals to 5. From the value of x that we got x equals to 2. Substitute. Meaning 2 all into bracket 2 plus 1 is equals to 5. Therefore, 4 plus 1 is equals to 5. Meaning 5 equals to what? 5. That is, the left hand side is equals to what? Right hand side. What does this mean? It means that for this equation, it has a unique solution. And the unique solution is what? When x equals to 2. Now let's check when x equals to 3. When x equals to 3, what does it mean? I have 2 all into bracket 3 plus 1 is equals to what? 5, right? And this gives me what? 6 plus 1 equals to 5. Which implies that 7 is not equals to what? 5. Meaning that for this equation to be true, or for this equation to be satisfied, the value of x, meaning the value of the unknown variable that will satisfy this equation is what? 2. And that's what it means by what? Unique solution. Comparing to this first equation, you have more than 2 values of x that will satisfy this equation. Which the first one was what? Plus 2, and the second one was what? Negative 2. That's what unique solution means. Now, many solution. The next one. Or before the next one, how do we represent this in a matrix form? You know, the idea of linear algebra is that we have different methods to be used, right? So what we'll be doing later on is that we're using matrix understanding to solve a system of linear equation, which is what? Gaussian elimination method, right? What's that?
And using matrix, and you know that matrix is also Gaussian, like
Yeah.
Yes.
Yes, that's it. So, how do we represent this in matrix form? We have x1 plus y1 plus z1 equals to a. This is equation 1, right? Then x2 plus y2 plus z2 equals to b. Equation 3. Equation 2. Equation 3, x3 plus y3 plus z3 is equals to what? C. This is equation 3. Now, from this equation 3, let's represent this system of linear equation in a matrix form. It is called augmented form of matrix. It is called what? The augmented form of matrix. Meaning you are using the coefficient of your equation. You know, in this case now, the coefficient in this case is what? 1, 1, 1, 1, right? So we want to represent this in an augmented form of matrix. So by unique solution, this is how you represent it in a matrix format. This is you saying, you know, this column in a matrix format, you are saying all value of x should take the first column, all value of y should take the second column, all value of z should take the third column. So by unique solution, this is what it means. You have 1, 0, 0, 0, 1, 0, 0, 0, 1. This is A, this is B, this is C. And this is X, Y, and Z. So what this means is that for this system of linear equation, the value of X, Y, and Z that will satisfy it is when X equals to what? A. When y equals to what? B. And when z is equals to what? C. Are you getting the idea? You are not getting it. Now this is it. From here. Do you understand what unique solution means? Any question? You already understood what unique solution means. When you say unique solution, what do you understand by the word unique solution? Unique solution is just saying that given this system of linear equation, what is the value of x, y, z that will make this equation to be true? When I say to be true, meaning the left hand side is equal to the what? Right hand side, right? Now consider this system of linear equation, same idea. You want to know the value of x, the value of y, and the value of z that will make the left hand side equals to the what? Right hand side. So what we are doing here is just for sake of explanation. Now the first thing you need to do is that represent this question in what? A augmented form of matrix. When we say augmented form of matrix, meaning you are taking the what? Coefficient. Taking the coefficient, normally this is what I would have done. 1, 1, 1, right? 1, 1, 1, 1, 1, 1. Then this is what? A, B, and C. But then we get to use this later. But just not under unique solution. This is what we are saying. This column is for what? X variable. This column is for what? Y variable. This column is for what? Z variable. Meaning that at the end, the value that you have here, this column, what you must have here is only for what? X. Similarly, what you must have here should be for what? Y. What you must have here should be for what? Z. Now look at row 1. If this is row 1, if this is row 2, and this is what? Row 3. If this is row 1, this is row 2, this is row 3. The idea is that row 1, to get the value of x, you obtain it from what? Row 1. Are you getting that off? You know, in this case now, the same way you have, this is column 1, column 2, column 3. This is row 1, row 2, row 3, right? Now, take note that to get the value of x from this augmented form of matrix, you are going to use what? Row 1. To get the value of y from this augmented form of matrix, you are going to use what? Row 2. To get the value of z from this augmented form of matrix, you are going to use what? Row 3. Now, to make that possible, looking at row 1, it means that you are going to eliminate some values. So at what column are you going to eliminate this value? At y and z. So if you are eliminating it, you can just write what? 0 and 0. We've started the Gaussian elimination method indirectly. But you get what I'm trying to say. Similarly, you are doing that for row 2. You want to get the value of y from row 2. Meaning that there are some columns that you are going to manipulate to become what? 0. And that will belong to what? Column 1 and column 3. Are you getting the point? So this becomes what? 0 and 0. Similarly for the third row, you then have what? 0, 0. Meaning in this case, what's the value of x? X equals to what? X equals to A, y equals to what? Y is equals to B, and Z is equals to what? C. But you understand it's better. This is not even my interest. My interest is that, say under unique solution, you've understood what a unique solution means. It means that for this system of linear equation, each value of x, y, and z have a distinct value that satisfies that equation. Now, take note that in a matrix format, this is how you represent it. So you really are saying x equals to A, y equals to what? B, z equals to C, where A, B, and C are real value. Now, let's change this A. Let's say this A is 2, and this B is 3, and C is 4. What it means is that x equals to 2, y equals to 3, and z equals to 4. So the value of the value of x, y, and z that will make this equation to be true, meaning the left hand side equals to the right hand side, it is only if x equals to 2, y equals to 3, and z equals to 4. Any value aside from this will not make the equation to be true, meaning the left hand side will not be equal to the what? Right hand side. And that's what unique solution means. And you can relate it to the definition, right? Don't worry, it will become more interesting when you start solving Gaussian elimination method. So any question before we move further on unique solution? Any question? Any question? No question. Take note that you can just write this. Under unique solution, pivots, there is a pivot in each column. There is a pivot in each column. You get to understand what pivot means later. There is a pivot in each column. This is spelling of pivot. Or you say pivot. Sorry, it is pronounced pivot. Under unique solution, there is a pivot, or you say pivot, anyhow you want to call it. There is a pivot in each column. Number 2, no contradiction. Then number 3, the determinant is not equals to 0. the determinant is not equals to what? 0. The next type of solution, it is called many solution, or you say infinitely many solution. So the next type of solution, it is called what? Many solution. Right, take down. By many solution, this is a type of solution. This is a type of equation. By many solution, I said this is a type of equation similar in nature, where the value of the unknown variables substituted satisfy the equation. This is a type of equation that is similar in nature, where the value of the unknown variable substituted satisfy the equation. Do you understand what that means? Okay, let's understand what it means. By many solution, just like as the name implies, unique solution, a distinct value. Many solution, different value of the unknown variables in this equation. Any value you substitute will definitely satisfy this equation, meaning the left hand side will be equals to what? Right hand side. Now let's consider this equation. Consider this algebra equation. The first one, when x equals to x, say equation 1. The second one, 2 all into bracket x plus 2 equals to 2x plus 4. This is equation 2. The third one, x plus 5 equals to x plus 5. This is what? Equation 3. Before we proceed, read the definition of many solution. Or what does it state? This is a type of equation similar in nature, where the value of the unknown variable substituted satisfy the linear equation. Now, what is the value of the unknown variable here? X, right? For this equation to be true, it means the left hand side is equal to the what? Right hand side. Now, given this system of linear equation, how do I know the value of x that will make the left hand side equals to the what? Right hand side. Are you getting the idea? Now, in this case, you can substitute any value of x. Irrespective of the value of x, your left hand side will be equals to the what? Right hand side. So I want us to do that together. Give me any value of x of your choice. When x equals to 2. When x equals to 2. When x equals to 2. For the first equation, meaning 2 is equals to 2, right? For the first equation, substituting x equals to 2, what do you have? 2 equals to 2, meaning that the equation is satisfied when x equals to 2. Still using the same value of 2, let's solve for equation 2. That becomes what? 2 all into bracket 2 plus 2, equating that to what? 2 all into bracket 2 plus 4. Solving further, this becomes what? 2 multiplied by 4 equals to what? 4 plus 4. Then this gives me what? 8 equals to what? 8. Satisfied. The left hand side equals to what? Right hand side. Now for the last equation, what do I have? 2 plus 5 equals to what? 2 plus 5. Meaning 7 equals to what? 7. Satisfied. This is when x equals to 2. Now give me another value of x. 4. What do you say? 4. When x equals to 4. Let's say when x equals to 4. When x equals to 4. Now for the first equation, what do I have? 4 is equals to what? 4. 4 equals to 4. Satisfied. For the second equation, what do I have? 2 all into bracket 4 plus 2, equating that to what? 2 all into bracket 4 plus 4. Right? This becomes what? 2 all into bracket 6, equating that to 6 plus what? Sorry? Equating that to 8 plus 4. And this gives us what? 12 equals to what? 12. Satisfied. Lastly, equation 3. What do I have? 4 plus 5. 4 plus 5 is equals to what? 4 plus 5. And this gives me what? 9 equals to 9. Satisfied. Can you now see what we are saying? Meaning for any value of x substituted into this equation, the left hand side will be equal to the right hand side. And that's what many solution is saying. That's what many solution is saying. Now let's see how we can represent this many solution in a matrix form, right? Just have the idea that this type of solution, they can be represented both graphically and in a matrix form. I get what I'm saying? For your type of solution, they can be represented both graphically and also in a matrix format. So for your many solution, how do you represent this many solution in a matrix form? Now, many solutions. By many solutions, this is how you have your matrix format. Let's interpret this. Still considering this same equation. Let's say this is our system of linear equation. And we've represented this system of linear equation using the augmented form. And after performing our reduction, meaning either you perform row reduction or reduce row reduction, you end up having this. What does this imply? It means, in this case, looking at this, what's the value of x? X equals to, don't forget that your row 1 gives you the value of x, your row 2 gives you the value of what? X, and your row 3 gives you the value of what? Sorry, row 1 gives you the value of x, row 2 gives you the value of what? Y, and row 3 gives you the value of what? Z. Now looking at this, what's the value of x? X equals to A, right? What's the value of y? Y equals to B. Now what's the value of z? Z equals to what? Do we even have z here? You know, by x equals to A, what we did was that we substituted this one as what? X, right? Similarly for what? Y. But in this case, can we say 0 is equals to z? It's not possible. You know, what we just did here was that we said 1 can be taken as what? X. In this case, 1 can be taken as what? Y. But yeah, I'm having 0. What do we do? And we have to know the value of what? X, Y, and Z. This is what many solution means. So by many solution, we assume Z as a parametric variable. By parametric variable, meaning T, where T is equals to what? Real numbers. Meaning T can be 1, 2, 3, 4, 5, 6, 7, 8. Just like we've seen in this case. You know, when X equals to 2, we saw that this equation was satisfied, meaning the left hand side was equals to what? Right hand side. When x equals to 4, same idea. Now in this case, we have the value of z. We don't know the value of z. We don't know the value of z. But what if we say that let z equals to t, where t is what? Real numbers. By real number, t can be 1, t can be 2. And if t is equals to 1, you agree with me that it will satisfy this equation, true or false? If t is equals to 2, you agree with me that it will satisfy these 3 equations. If t is equals to 10, you also agree with me that it will satisfy these 3 equations. So in essence, we are saying that irrespective of the value of t, meaning z, is going to satisfy all your equations. And that's what many solution means. You understand better when you start applying all of this to a given question. So let's write. What do you have here? What do you have here? Okay. In this case, z equals to t. By t, a parametric variable. When we say parametric variable, meaning real numbers, t can be equals to 1, t can be equals to 1, it can be equals to 2, it can be equals to 3, it can also be equals to 5, and continuously. And meaning that, okay, let's stop at 10. Okay, let me just say t can be equals to 1, 2, 3, 4 in brackets. Real numbers. Any question on that? Any question on that? Meaning that given a question or given a problem, and you know that this problem is many solutions, what does it mean? It means that the value of z must be known. Or let me just explain what this thing means to you. What this thing means is that what you are saying is that given this type of system, given this system of linear equation, and you want to know the value of what? Z, x, y, and z. How it works is that the value of z must be known first. Are you getting me? The value of z must be known because x and y depend on this z. X and Y depend on this word Z. But you understand better, don't worry, you understand better when you start solving. So what do we have under many solution again? Okay, you can write none. Okay, in this case too, take note that Z in this case is called free variable. Z is called what? A free variable. Z is called a free variable. What do you understand by the word free variable? By free variable, what it means is that you can substitute any value for Z. You can substitute what? Any value for Z. Just like the way we substituted x equals to 2 and 4. You know, when we substituted x equals to 2 and 4, this equation was met. This equation was satisfied. Now, same idea. In this case, what value of Z? We don't know the value of Z. So we are saying let Z equals to T. Let T equals to what? 1, 2, 3, 4. Meaning real numbers. In some cases, depending on your assumption, T might be equals to 100. You are still correct. So by that, it means that Z equals to what? Free variable. By free variable, you can assume any number for Z. That's what it means. So take note, under many solutions, number one, Z is a free variable. Z is a free variable. And number two, a free variable occur under a non-pivot column. A free variable occurs under a non-pivot column. Now, moving on to the last one, no solution. No solution. By no solution, this is a type of solution. This is a type of solution where the value of the unknown variable. This is a type of solution where the value of the unknown variable substituted did not satisfy the equation. Meaning, the equation is not true for that value of unknown variable substituted. Let me repeat that. No solution. This is a type of solution. This is a type of solution where the value of the unknown variable do not satisfy the what? Equation. Meaning that value substituted do not make the equation to be true. Now, let's take an example of this type of solution. Let's take an example of this type of solution. The first example that we have here, when our first example, x plus 1 equals to x plus 2. Say this is equation 1. Then the next one, 3x equals to 4x. Say equation 2. The other solution, which was many solutions. By many solutions, what we just did was that we assume any value of x, right? When we assume any value of x, we saw that the left hand side was equal to the what? Right hand side. That's for many solutions. Meaning, irrespective of the value of x you assume, the left hand side will definitely equal to the what? Right hand side. Now, for no solution, it is telling us that no matter the value of x substituted, the left hand side will not be equal to the what? Right hand side. So these are type of solution, or these are type of equation. Now, let's assume any value of x. Let's give me any value of x. Let's say when x is equal to what? 3. When x equals to 3. For the first one, what do we have? We have 3 plus 1 is equals to 3 plus 2. This becomes what? 4. And this is what? 5. What does this mean? We are saying 4 equals to 5. Is that possible? No, meaning 4 is not equals to what? 5. Meaning for this equation, no solution. Similarly, for the second type of equation, still using this value of x, when x equals to 3, we then have 3 all into bracket 3, right? Equating that to 4 all into bracket 3. This gives me what? 9. And this gives me what? 12. Meaning that what we are saying is that 9 equals to 12. Is it possible? Is 9 equals to 12? Therefore, 9 is not equals to what? 12. So for this equation, it has what? No solution. This equation has no solution. So the first one was what? Unique solution. By unique solution, the value of x, y, z that will satisfy that system of linear equation is just one value. Any value aside from that value of x, y, z will not satisfy that system of linear equation, right? Then for many solution, for unique and okay, whereby it will not that's why we need to understand the different type of solution. So in that case, what this is just a guide, in the sense that once you have something like this, you'll be able to categorize that, okay, this is a unique solution, this is many solution, this is no solution. Are you getting me? But you see what I'm saying? Any questions so far? So we have three different type of solution. The first one is what? Unique solution, many solution, and no solution. And each of these solution, we represented them in a what? Matrix form. So let's do for no solution. When we say no solution in a matrix format, still considering this as a system of linear equation. Say this is your system of linear equation. How do you represent no solution? You have it as 1, 0, 0. This is A, 0, 1, 0. This is B, 0, 0, 0, C. Yeah. Alright, let's interpret. Now for many solutions, we said this is how we represent it in a matrix form. This is how we represent it in a matrix form. This is our first row, this is row 2, and this is row 3. What's the value of x, what's the value of y, and what's the value of z here? X equals to what? X equals to A. X equals to A. Y equals to what? Y equals to what? B. What about Z? What about Z? In this case, do we have Z? No, because the column for Z, we already have what? 0. We already have what? 0. Meaning in this case, C is equal to 0, which is equal to what? Z. So how do we relate this to what we did previously? It means no matter the number of Z that you substitute, it will not satisfy that equation. The first equation was what? X plus 1 is equal to what? X plus 2. Now, what I'll be doing is that I want to relate this. We want to interpret this. We want to interpret this with respect to what we've done before. Now, in this case, what's the value of x? X equals to what? A, right? What's the value of y? Y equals to what? B. Now, what's the value of z? Z equals to what? 0. Z equals to what? 0. Meaning when z equals to 0, you have no solution. Are you getting me? When z equals to what? 0, there is no solution. Even when you substitute a value greater than 0, you still have what? No solution. Now let's apply it here. In this case now, let's say when x equals to 1, what do we have? 1 plus 1 is equals to 1 plus 2. And this will give us what? 2 equals to 3, which is not equal. Right? When x equals to what? 2. This will give us what? 2 plus 1 equals to 2 plus 2. And this is what? 3 not equals to what? 4. Similarly, when x equals to 0, same thing happens. Right? So this becomes what? 0 plus 1 equals to what? 0 plus 2. That is, 1 is not equals to what? 2. So you are generalizing it, saying when z is equals to 0, there is no solution. When z equals to 0, there is no solution. So you need to know the difference between these three types of solution. For the first one, there was a value for z, right? Meaning z was equals to what? C. For the second one, what's the value for z? What's the value of z? Z is what? A parametric variable. What we are getting? Yes. For the unique solution, we got the value for z, which was what? Which was 1, meaning z equals to c. Meaning z can only be equal to c at that instant. Any value aside from z, it will satisfy that equation. That's for unique solution. Now for many solution, what was the value of z? Z equals to t. Meaning where t is what? A parametric variable. Meaning that you can consider t to be any number. That equation will still be satisfied. When t is equals to 1, that equation will still be satisfied. When t equals to 2, 3, that equation will be satisfied. But for no solution, when z equals to 0, there's no solution. When z equals to 0, there's no solution. That's what we are saying. So this is the matrix representation. So you can also write under no solution. Let's write the system of linear equation is inconsistent. The system of linear equation is inconsistent. The system of linear equation is inconsistent. And you remember that I told us that what's the purpose of linear algebra? Why are we doing linear algebra? We want to look at linear algebra in an advanced part or in an advanced form, unlike the linear algebra that we know. Normally, say you want to solve any question under linear algebra, apply simultaneous equation. Your interest at that moment is to get the value of x, y, z. But in this case, we want to see it in another dimension, another dynamics. And the dynamics says that we want to comment on our answer. We commenting on our answer, we want to know if this system of linear equation is consistent or not. If it is consistent, we apply it to any practical scenario. If it is inconsistent, we also apply it to any practical scenario. That's why we need to know these different type of solutions. So we have for unique solution. Unique solution means it is consistent. Many solution, it is consistent. No solution, inconsistent. So in the end, we have two different type of equation: consistent equation and inconsistent equation. Consistent equation is when your variable has at least one value that will satisfy this equation. Your unknown variable in that case might be more than one, but the fact that it can still satisfy that equation, it is a consistent equation. Do you know the difference between consistent and inconsistent? Or I should explain again. I said by consistent equation, it means that your system of linear equation, your system of linear equation, you have unknown variables, right? So by consistent, it is telling us that if this unknown variables has at least one value that will satisfy that equation, meaning that will make the left hand side to be equal to the right hand side. Mind you, your unknown variables might have more than one value that will satisfy it, but at least it must have what? One value. It might be greater than one, but the point is that it must have at least one value. Now compare it to the one that we said it is inconsistent. Why do you think this guy is inconsistent? Because z does not have any value. Z was 0 here. Are you getting the idea? Now, by unique solution, we said x, okay? Considering this system of linear equation, we have z, we have y, we have x, we have y, we have z. Now, for unique solution, this x has a value, a distinct value, right? This y also has a distinct value. This z also has a distinct value. Meaning, it makes that system of linear equation to be a consistent equation. Why? Because each of these guys has at least one value. Mind you, it might have more than two values. We are less concerned with that. But the fact that it satisfies the equation, we are good to go. Meaning, it makes that system of linear equation to be what? Consistent. That's for unique solution. For many solutions, you agree with it that x has more than one value that will satisfy the equation. True or false? Y also has more than one value that will satisfy the equation. Similarly to what? Z. Now, for no solution, x has a value, right? Y has a value. What about z? It has no value. So because z has no value, it makes the system of linear equation to be what? Inconsistent. Let's say, for instance, we have z equals to c. What does this mean? Consistent. Why is it consistent? Each of these unknown variables has a value to satisfy the system of linear equation. We now see the reason why we need to know these theorems, or we need to know this type of solution. We knowing this type of solution will make us to come into conclusion saying my system of linear equation is a consistent equation or inconsistent equation. And that's what we are interested in as an engineer. Beyond solving, we want to know if this system of linear equation is consistent or inconsistent. And that's it. Alright, what else? Now, I also mentioned that this type of solution, we can represent it both graphically and what? In a matrix form. So we've interpreted this type of solution using what? Matrix form. Now let's see how we can interpret it using a graphical form. When I say graphical form, meaning your Cartesian coordinates, x and y and x axis. So let's say you're under your unique solution. Let's say this is y. Let's say this is y, and this is what? x, right? Your unique solution, by unique solution, what do you at this level now, what do you understand by unique solution? It has what? A unique number, meaning each of those unknown variables has just one number to satisfy that what? Linear equation. So maybe drawing something like this. Let's say this is your first equation, just like the way we've seen. Let's say y is equals to f of x. This is your first equation. The second equation, when y is equals to f of x. Mind you, when I say y equals to f of x, it can be x plus 4. This might be x plus 2. Okay? This might be 2 plus 4x. I believe you get what I'm trying to say. So that's it. This line represents an equation. This line also represents an equation. Any question on that? So meaning under unique solution, let's say we have two equations. This is the first equation and this is the second equation. Graphically, we are saying that these two equations, the line that represents these two equations on our graph, it intersects. Are you getting me? This equation, this first line is for this equation, meaning when y equals to f of x subscript 1, that is x plus 4. This is the line that represents this equation, meaning when y equals to what? X plus 4. This is the line that represents this equation when y equals to what? 2 plus 4y. So graphically, we are saying these equations must meet at a point. All of these equations intersect at a point. What if it is more than two equations? Same idea. All of these are intersecting at a point. That's for unique solution. Now, for no solution. When you say no solution, what's the idea? No point of intersection. Meaning, this line will be parallel to each other. They will never meet. True or false? True. So, by no solution, let's say this is what? X. And let's say this is what? Y. So, this line is representing your first equation. Let's say when y equals to f of x subscript 1. This other line, it is representing your second equation when y equals to f of x subscript 2. So meaning that these two equations, they are parallel to each other. They are not going to meet. They will never touch each other. That's for no solution. For no solution. Now for many solution, what does it mean? What do you understand by this? Representing many solutions graphically. How can we do that? We know that it has more than. We know that these unknown values has more than what? One value. So these unknown variables has more than one value. These unknown variables has more than what? One value. So this is our graphical representation. Let's say this is y. Let's say this is y. And let's say this is x. So you just have a single line. This single line, it is telling me that y can be equals to what? F of x subscript 1. Y can be equals to what? F of x subscript 2. Y can be equals to what? F of x subscript 3. So meaning that for this very guy, for this first one, it satisfies that system of linear equation. That's the meaning. For this same line, it also satisfies what? That system of linear equation. Then lastly, this also satisfies what? That system of linear equation. So we already have the full understanding of the different type of solution that we have. Mind you, this is just the basic. We've not started anything yet. But I must say that once you know this, you have no stress. You just be flowing. Since you already have the understanding, all you need is the understanding. Once you have the understanding, by the time you solve, you'll be able to reference back to all of these theory explanation that we've been doing since morning. Alright, moving on. Alright, another subtopic. Terms to know. The terminologies, terms to know, and we've dealt with few of these terms already. Terms to know under linear algebra. Few terms to know under linear algebra. The first one, inconsistent equation. Inconsistent equation. The second one, consistent equation. Terms to know. The first one is what? Inconsistent equation. The second one is what? Consistent equation. The third one, dependent variable. The fourth one, independent variable. The fifth one, we have free variable. Number 6, we have the pivot, or you say pivot. And the last one, we have the augmented form of matrix. We have the augmented form. The argument form of matrix. I said the terminologies to know. The terminologies, or you say the terms to know. The first one is what? Inconsistent equation, meaning that after solving a system of linear equation, how do we come into conclusion? How do we come into conclusion as an engineering student, or you say as an engineer? The first one is that we must understand what inconsistent equation means, or we must understand all these terminologies, all these terms. The first one is what? Inconsistent equation. Number 2 is what? Consistent equation. Number 3 is dependent variable. The fourth one is independent variable. The fifth one is free variable. The sixth one is what? Pivot. And the last one is augmented form of matrix. And I've explained inconsistent, consistent, free variable, pivot, and augmented form of matrix. True or false? So let's look at it one after the other. The first one, inconsistent equation. What do you understand by inconsistent equation? What's the understanding of inconsistent equation? When there is no solution, exactly. When there is no solution. And how do you know if there is no solution? There is a particular point I need. When the value of z equals to 0. Meaning, out of these unknown variables, when one of these unknown variables has no value, which in this case is what? Z. You understand? Inconsistent equation. What does it mean? No solution. How do you come into conclusion that this is no solution? Meaning, out of these unknown variables, one of these unknown variables, there is a particular variable that the value is unknown, which is always what? Z. Meaning, if Z is 0, if Z is unknown, that system of linear equation is what? Inconsistent equation. Number 2, consistent equation. What does it mean? At least this unknown variable must have one value. Consistent equation means what? These unknown variables, at least this unknown variable must have one value. At least these unknown variables must have one value to satisfy that system of linear equation. Mind you, it is possible for it to have what? More than one value, as far as it satisfies that system of linear equation. Number 3. Okay, before number 3, let's look at free variable. What do you understand by free variable? What type of solution gives us free variable? Manysolution gives us free variable. By free variable, it means you can substitute any value of z, and we've generalized that let z equals to t, where t is a parametric variable. By parametric variable, real numbers. It can be 1, it can be 2, it can be 3, it can be 100. That's the idea, many solutions. Now, the next one, augmented form of matrix. What do you understand by augmented form of matrix? Meaning, represent the system. Looking at your system of linear equation, you are interested in the coefficient. You are interested in the what? The coefficient of your system of linear equation. Then represent it in a matrix form. Let's say you have this matrix format. 3x plus 4y plus z is equals to 8, equation 1. Equation 2, 2x plus 2y minus 3z is equals to 4. Equation 2. Equation 3, x plus y plus z is equals to 3. Equation 3. And you want to write the augmented form of this matrix. By augmented form, observe the coefficient of equation 1, observe the coefficient of equation 2, and observe the coefficient of equation 3. Now let's do that. Representing this in an augmented form of matrix, the augmented form of this system of linear equation becomes what? Your row 1, what do you have? 3, 4, 2, 3, 4, 1, 3, 4, 1, 8, right? Row 2, what do you have? 2, 2, negative 3, 4, and the last one, 1, 1, 1, and 3. And this is your first step when it comes to Gaussian elimination method. Then, any question on augmented form? You will understand what it means now by augmented form of matrix. Then the next one, dependent variable. When we say dependent variable, as the name implies, what does dependent variable means? What type of solution will give us dependent variable? Dependent variable. Dependent variable. Unique solution. Many, why? Quote it, like tell me why.
The so other depends on z. Like x and y depends on z.
X and y depends on z. Yeah, that's correct. That's correct. Dependent variable is for unique solution. Let me just put it that way. When you say dependent variable, it is for unique solution. But independent variable, you can choose freely. So independent variable is for many solutions. As the name implies, independent. Independent, you are free. You can decide any value of z to use. But dependent, you can't decide any value of the unknown variable to use. Are you getting that? You know, for many solutions, you want to know the value of x, the value of y, and the value of z that will satisfy this system of linear equation. Say you are doing this system of linear equation now. To confirm that the left hand side is equals to the right hand side, you must have known the value of x, y, z, then substitute back. Let's say x is equals to 1, y equals to 2, and z is equals to 4. It means that by the time you substitute this value into equation 1, the left hand side must be 8, meaning 8 equals to 8. By the time you substitute this value into equation 2, the left hand side must be what? 4. 4 equals to 4. Similarly, by the time you substitute this value into equation 3, it means you must get 3. 3 is equals to what? 3. Now, by unique solution, you know that from unique solution, this value that will satisfy this equation, the unknown variable, you know, these are the unknown variables, right? X, Y, Z are the unknown variables. The value of the unknown variable that will satisfy this equation is not more than 1. Is not more than 1. Meaning it is dependent. It is dependent. By dependent, you cannot decide the value to use. You can't decide the value to use. The value that will satisfy it, the value that will make the left hand side to be equal to the right hand side, it depends on the value that we've gotten. If you assume another value, it will be wrong. And if you get it wrong, it means the left hand side is not equal to the right hand side. How do you make the left hand side to be equal to the right hand side? It depends on that value that you've gotten. Are you getting the idea? Now, many solutions, that's independent variable. By many solutions, you are saying if x equals to 1, y equals to 2, z equals to 3, and x equals to 2, y equals to 4, z equals to 2. These values of this unknown variable in each instance, say case 1 and case 2, we satisfy this equation in such a way that the left hand side will be equal to the right hand side. Meaning at this instance, it does not depend on either of this or this. Say case 1, say case 2. Meaning the value of the unknown variables that will satisfy the system of linear equation do not depend on either 1 or 2. You can use any of these, it will still satisfy it. Do another assumption, it's still going to satisfy it. You get what it means now by dependent variable and independent variable. So meaning independent variable, you can choose freely. You can choose what? Freely. Then dependent variable, it is restricted. You can't choose freely. That's what it means in a simple term. So by definition, you can take down. Just take down. And you see that we reference back to all of this. Dependent variable, when the variable is restricted. Dependent variable, when the variable is restricted. Dependent variable, when the variable, dependent variable, when the variable is restricted. Dependent variable, dependent variable, it means that the variable is restricted, or this is a type of variable when the variable is restricted, that is only a set of unknown values, only a set of unknown values, that is only a set of unknown values of variable can satisfy the equation. Hope you understand that. When the set of variable is what? Restricted, that is only a set of unknown value of variable can satisfy this equation. Then the next one, independent variables. You can freely choose different value. You can freely choose different value of the unknown variables to satisfy the equation. In brackets, this occurs in a non-pivot column. This occurs in a non-pivot column. Write the first one. It occurs in a pivot column. We will look at what pivot means. I said, what's the definition that I gave you guys for the first one? For the first one, what's the definition for dependent variable? When the variable is what? Restricted, that is a set of unknown value of this variable can satisfy this equation. In bracket, it occurs in a pivot column. Then for independent, what does it say? You can fully choose a value for the unknown variables that satisfy this equation. In bracket, non-pivot column. Now, what do we mean by pivot, or what does pivot mean? We reference to pivot when we define both dependent variable and independent variable. Now, pivot by definition, it is a non-zero leading entry. It is a non-zero leading entry. It is a non-zero leading entry in a row, typically after reduction has been done. It is a non-zero leading entry in a row, typically after row reduction has been done. Typically after row reduction has been done. Typically after row reduction has been done. Now, by row reduction, we are saying that you need your pivot. Let me bring back to this, explaining dependent variable and independent variable. Earlier, under unique solution, we have something like this: 0, 1, 0, 0, 0, 1, right? A, B, C. Then we also have something like this: 1, 0, A, 0, 1, 0, B. Then the last one, 0, 0, 0, 0. Then the next one becomes 1, 0, 0, A, 0, 0, 1, 0, B, 0, 0, 0, C. So this is what? This is what? Unique. This is for unique solution. This is for what? Many solution. This is for many solution. This is for many solution. And this is for what? No solution. Now I said, as an engineer, given a system of linear equation, perform your row reduction. After performing your row reduction, depending on the type of solution, make your comment. How do you make your comment? You use this to make your comment. Now, let's say you are given this system of linear equation and you perform row reduction. You got this, right? Meaning unique solution. By unique solution, is it consistent equation? Is it a consistent equation? By unique solution. Why is it a consistent equation? It is a consistent equation because each of these unknown variables has at least one value, right? Has at least one value, which in this case is what? X equals to A, Y equals to B, Z equals to C. Now, another question we need to ask ourselves, is it a dependent variable or independent variable? Now, read the definition of dependent and independent variable. When the variable is restricted, that only a set of this unknown value will satisfy this equation, will make this equation to be true, right? Now, in this case, is it dependent variable or independent variable? What do you call it? What do you call it? Dependent. Read it again. But unique solution, let me use value. Say this is 2, this is 3, and this is 4. Using this as a reference. Using this as, let's say case study. Let's say we are using this as a reference. Now, what you are saying here is that x equals to what? 2. Y equals to what? 3. And z is equals to what? 4. Now, let's say this was imagine this being the equation given, that you perform a reduction, you got this. Meaning that, your aim is that left hand side must be equal to the right hand side. So, what you are saying is that for this left hand side to be equal to the right hand side, the only value of x, y, z that will make that true is when x equals to 2, when y equals to 3, when z equals to 4. Any value aside from this will not make it to happen, or it will not be true. Right? So now read dependent variable again. When the variable is restricted, meaning only a set of unknown value of this variable can make this equation to be satisfied or to be true. So under unique solution, what are you saying? It is a dependent variable. And it is also what? Consistent equation. Why is it a consistent equation? Because it has at least one value. The unknown variable has at least one value. Now, let's go to many solution. That will be what? Inconsistent equation and what? Dependent. Don't worry, you do it together. You make that comment together. Now, many solution. Let's start from the first one. Is it a consistent equation or inconsistent equation? Why is it inconsistent? Because we can choose freely, right? You can choose freely. By choosing freely, we are saying, let's say case 1. X equals to 1, y equals to 2, z equals to what? Z equals to 3, right? Then this same equation, when x equals to 4, we've commented on unique solution and what? No solution. Now I want to make our comment on no solution. Let's make our comment on no solution. Where did I even stop? Okay, yeah. We said since this is what? Independent variable. By independent variable, what does it mean? It means also a free variable. Why is it a free variable? By definition, independent variable says you can choose freely. You can what? Choose freely. So this is also what? This is also a free variable. This is also a free variable. And take note that we made mention of pivot column and non-pivot column when we defined dependent variable. We said dependent variable occurs at what? A pivot column. A pivot column. We are going to look at what that means. Why this occurs where? Non-pivot column. Right? What about, let's make our comment on no solution also. Is there any comment to make on no solution? What's the condition of no solution? We can say that this is what? Inconsistent, free variable, and what? Independent variable. Why? Because you can choose freely. But the idea here is that the left hand side is not equal to the right hand side. But we are interested in the right hand side being equal to what? Right hand side. And that's what linear algebra means basically. When we started the class, we said linear algebra is a branch of mathematics that deals with the study of system of linear equation. and it determines the unknown variable present in this equation that make this equation to be true or to be satisfied. Meaning, is the left hand side equals to the right hand side? Once this is true, depending on how we got the left hand side being equal to the right hand side, if it was a unique solution or many solution, this is the comment for unique solution and this is the comment for many solution. So with this, we'll be able to apply this knowledge practically as an engineering student. I said it, one of our lecturers once said that the difference between engineering student and mathematician is that as a mathematician, they only solve, they only compute those values. But we as an engineer, we will bring this thing to life. Now, let me give you a practical example. As a civil engineering student, let me give you a practical example. Let's say you have a slab, and this slab, it only has 4 columns carrying this slab. I believe you know what a slab means. A decking, this is a slab. And this slab only has 4 columns carrying this slab. Let's say the total magnitude of this slab is 800 kilonewton. Let's say it is 800 kilonewton. And how many columns do I say you have? 4. The question becomes, this column, the distribution of the magnitude of this column, are they equal? Is it 200 overall? Like each of these columns, is it 200? Or one is more than 200? Are you getting that though? Let's say you have a slab or you say you have a beam and you have about 4 supports. You know, depending on the weight or depending on the load a particular span is carrying, will determine how the magnitude of that support is. Probably the magnitude will be greater than that of the other. Now, I'm not saying the total weight or the total intensity of that structural member, which is slab in this case, is 800 kilonewton. As an engineer, the question we are going to ask ourselves is that, am I distributing to 200 each for this column, or one will be 400, while the other will be what? 150, or while the other will be what? 50. Now imagine it is a unique solution. What does it mean? Each of these columns must have what? 200. Are you getting it? Meaning each of these has what? A distinct value. In some cases, let's say it is a many solution, meaning it can vary. One might be 400, the other might be 300, the other might be 150. But the idea is that it is still going to carry that same slab. Are you getting it? I'm giving you a practical scenario now. That's why we need to understand all of this. Not just that we are doing it in money. We need the understanding. So the same way I've given a practical scenario in civil engineering, it works for every other engineering. Mechanical engineering, agric engineering, electronics engineering, mechatronics. Also, mechatronics guy, they also use it when it comes to coding. So that's how linear algebra works. It has a lot of application. So this is the theoretical explanation when it comes to what? Linear algebra. This is the theoretical explanation when it comes to what? Linear algebra. Now, we've seen that we have different types of methods to solve what? We've seen that we have different types of methods to solve a given question under linear algebra. So we'll be looking at what? Reduction method. We'll be looking at what? Reduction method. Why are we looking at this reduction method? We are looking at this reduction method because it is easy. Let me just say it is easy. You know, you can also use Cramer's method, but by Cramer's, you have to know the determinant. X equals to delta 1 over the overall determinant. Y equals to delta 2 over the overall determinant. Z equals to delta 3 over the overall determinant. But by that you know Gaussian elimination method, I must say that you should I say you not even like Cramer's method, or you find it very easy to solve any question, and it prepares ahead of the next topic, which is engine value and engine vector. So that's just it. So we'll be looking at row reduction, and I've said that when it comes to row reduction, we have Gaussian elimination method and Gauss-Jordan elimination method. By Gaussian elimination method, it is referred to row echelon form. Gauss-Jordan elimination method, we use row echelon form. And this row reduction that we are saying, this is the row reduction. Imagine you decomposing something of this nature. You know, earlier, write the augmented form of this matrix. By the augmented form, 3, 4, 2, 8, 2, 2, negative 3, 4, 1, 1, 1, 3. Imagine you decomposing something like this to this. See how easy it is. From here, this was the given question. You reduce this, or you reduce the rows. You know, this is row 1, this is row 2, this is row 3. you reduce row 1 to row 1 of this. You reduce row 2 of this to row 2 of this. You reduce row 3 of this to row 3 of this. Mind you, these two guys, they are equivalent, they are the same. Meaning, looking at this, you can say that s equals to 2, right? You can also say that y equals to what? 3. You can also say that what? Z equals to what? 4. How do you do that? Looking at your matrix. You can do that easily looking at your matrix just by decomposing this guy. And that is what Gaussian elimination and Gauss-Jordan elimination means. So, all right, let's take the next topic. You can write Gaussian subtopic, Gaussian elimination method / or say Gaussian elimination method and Gauss-Jordan elimination method. Gaussian elimination method or Gauss-Jordan elimination method. We'll be looking at Gaussian and Gauss-Jordan in the next video. If you find this video helpful, give it a thumbs up, do well to subscribe, and see you in my next video.